Welcome. Very good morning. In today's lecture, we will discuss on regression modeling using SPSS software. It is under supplement. So you will see that how SPSS can be used for conducting regression, or other way I can say solving regression problems. Let us go to the next.
Now we will discuss regression models using SPSS. SPSS is known as Statistical Package for social scientists. Statistical package for social sciences. It's a vast software. I think you will find out that almost all types of statistical analysis is possible using SPSS, and nowadays the data mining and other advanced techniques are also available in SPSS. So, what we will discuss now, I will first show you that how to enter data in SPSS spreadsheet. Then we will see that how the some simple graphs, for example histogram, scatter plot, all those etc., how this can be done using SPSS. Then I will show you that one-way ANOVA, although the topic is regression models using SPSS, but I will show you in one way, and then how one-way ANOVA, because this is the first model class we have taken, one-way ANOVA using SPSS. Then I will go to linear regression. Okay, so that means multiple linear regressions, basically linear regression in the multiple as well as simple. So we can use this one, multiple linear regression model. Then I will show you that multivariate linear regression, MVLR. Okay. As we are discussing this one-way ANOVA, so we may be also interested to know how is MANOVA possible in SPSS or not. MANOVA also using SPSS you can run MANOVA, but I am not sure that all these will be completed by this lecture. Later on we will go for one more, that SPSS demonstration if requires. So, you see this one is the spreadsheet for SPSS. Now, how I have brought data into this sheet. For example, if I am just closing down this one. So, you go to SPSS, we are using here SPSS 17. Now, if there are earlier files what you have used, then it will ask you whether you want to open one existing file or not. For example, you do not want to open any existing file, so then you put OK. This is what it is asking for existing file, so you do not go for existing file. Okay. Now, there are two windows, one is data view window, another one is variable view window. So, you come first variable window and create some variable, for example, x1. Then what type of variable it is? If you click here, you will find out that the variable type can be numeric, comma, dot, scientific notation. So, whatever way one captures data, that is given here. For example, let us this one is a x1 is a numeric variable, and we are giving the width 8 and decimal places 2. So, that means up to 2 decimal places you will be storing here. Then OK. Give one more, suppose let it be y1, and this one also your numeric with same thing. Then you put x2, let this one is a string variable, this is a string variable. So, then the symbol of string variable is like this, and when the measurement is nominal, that is why the string. So, I think you can recollect that one what we have discussed in data types, that nominal, interval, nominal, then ordinal, then your interval, then your ratio. So, when it is said scale data, this basically coming from these two, and they are also saying nominal data. Okay. So, you can make this one, suppose if I click this, see that scale, ordinal and nominal, it is available here. So, if you want to make it ordinal, click like this. So, in case of ordinal data, there will be bar chart type symbol. Suppose this one is nominal scale data. So, you want to make it nominal, make it like this. So, here also you have to change accordingly, you have to go for string, and accordingly you have to change. Okay, we will not change. So, this one measurement is our scale measurement automatic, this one is nominal measurement, let it be like this. So, this is what is known as you have defined the variables. You can label the variables, but for the time being we are not interested in labeling. So, go to the data view. What has happened here? You see x1, y1 and x2, these 3 variables are created, and we have said that x2 is string variable, x1 and y1 are numeric variable. So, put some value. For example, let this is 10, then 15, then 20, then 25, let it be 30. So, y1 let it be 5, let it be 9, let it be 12, then followed by suppose 20, followed by let it be 22. Then x, we are saying that 2 types nominal, that is nominal we said. For example, I will keep 1, 1, 2, 2, 2. I have given numeric values here 1, 1, 1, 2 like this, but you can type also, you can give some other string variable. So, this is, let it be, it is our data sheet. Now, but it is, this spreadsheet is similar to Excel spreadsheet, we have seen in Excel also. So, instead of entering data directly in SPSS spreadsheet, you can import data, copy it or stored in Excel file, that is also possible. Okay. So, let us see how can you do this. Suppose you go to open, then go to the file where the data is there. Suppose I am going to the file where this data is available. Suppose this is the data folder. So, see here these data, these are all SPSS data. Now, I want to go to Excel data, there is Excel command also. You see, once you click here, you will get Excel column. For example, we will take one data set like this, for example, this one, click here and then make open, then one comment will, it's come, it is asking read variable names from the first row of the data, variable name from the first row of the data, and if you say OK, then see all the variables and the related data are available in the SPSS folder, correct. So, if you go to the variable view, you see that copper, silicon, nickel, phosphorus, hardness, speed, all those variables are here. Their data type is numeric with given, and their label also given, and all are measured in ratios, that scale data, everything. So, that means your data is ready in SPSS spreadsheet, and now you can do whatever you want to do with this data. Okay. So, let us see some of the graphs. See, there is one column, if you add there is one tag is there, that is graph, then analyze, then transform. So, file, edit, view, data, transform, analyze, graphs, utilities, so on. So many fields are there. Now, I will go to graph. There are chart builder, there are some template, but we will go by the legacy dialogues. Here, for example, bar chart you choose. So, you can choose bar chart, simple, cluster, stack. Let us choose this one, first one, that summaries for group of cases, summaries for separate variables, values of individual value, the first one you take. Then what it is asking? It is asking what is your category axis and what are the rows and other things. So, bars represent number of cases, let it be. So, I want to give which variable we will give. I think this feed, this is showing 111. So, let us give this one. Okay. Now, put OK. See, this is the speed has 6 to 10, 6, 7, 8, 9, 10 different. Actually, this is not 6, 7, 8, 9, 10, these are the speed values. If you, I think there is, if I go back, I want to see what we have taken speed value, not feed value. So, let me go back to the data again. Here decimal is, no decimal is considered, I am considering second decimal up to decimal 2. Now, go back, see ultimately that all those 1 values now 1.1, 1.2 like this. So, I am again going back to your legacy graph and bar chart. We have taken the first one, then this is fine. We have taken speed, but we want to take the feed one. So, feed, you see that what are you getting? There are two levels basically. One is 1.10 and another is 1.20. Okay, although this 1.10, 1.20 is numerical value measured in scale, but actually the process is operating under these two feed conditions, revolution per minute. Now, if you want to go for some other type of, for example, suppose you may be interested to know scatter plot. For example, simple, then this one is simple scatter, define what will be x axis, let backlash is your x axis, what is your y axis, let speed is your y axis. So, many things now you can set marker, labels, other that options are available. We will just go by these two and see what is happening here. This is the scatter plot what I have shown you earlier under that linear regression, multiple regression class. What it is happening here? It is showing that backlash decreases with increase in speed, correct. Now, you may be interested to find out some of the descriptive statistics. For example, let it be frequencies. Then, if you can select one variable at a time. You can select all variable just pressing tab. First, how do you select all variable? First, click on a particular variable, then press tab, then finally press the last one if you want to take, then this all. There are statistics what you want, quartile, some points, mean, median, mode, so many things are there. For example, I want the mean and I want standard deviation, these two only, so make it okay. You see that for the all the variables, what are the total data points, how many missing values are there, and then what is the mean value and what is the standard deviations, everything coming. And frequency table is giving basically what are the observed values under different, so it will be a big one because 100 some cases 100 data points are there, so very big. When you have continuous data, then the frequency table is not meaningful. For example, you see that these are all humidity, but depth of cut is measured under this 7 scale, probably 1, 2, 3, 4, 5, 6, 7 different categories, 0.75 to 1.40. For this it is meaningful because your frequency is there, different cells, different level of frequency. Okay. Now let us so if you are interested further, suppose you want to develop histogram, I think this is histogram. So you choose the variable for which you are interested to know the histogram. Okay, if you want to display normal curve, click there. Okay, you do it. So your histogram is plotted. Actually, this is not a perfect normal distribution. There is certain data problem, for example here, but on this type of histogram you will find out because this is coming from the actual production shop. Okay, you can create, but from actual production shop we have collected this data, and as a result you are getting like this. Okay. Now I will show you that the analysis part, what are the options available under analysis. First one is report. In a report, it is basically the preliminary data mining types of thing. The OLAP cubes is there, then you will summarize in rows, in column, all those things are there. Then descriptive statistics starting from frequency, descriptive, explore, crosstab, ratio, PP plot and QQ plot. For example, you want to develop PP plot. For which variable you are interested to develop PP plot? For example, we are interested for backlash and contact. And what is the test distribution you are looking for? Let it be normal. So now there are many options. You can transform the data, you can, that proportion estimate is available, rank assigned to tie is available, and you have to understand this. For example, if by chance you are not able to understand what is this, you click help. Once you click help, then as you have chosen PP plot, it will explain what is PP plot. So you may be interested to go some related topics, for example QQ plot, for example how to obtain PP plot. So these are possible, and then next slowly these different tips you will be getting, and which will help you while analyzing through SPSS. Okay. Okay, fine. So we know what is normal probability plot, we have discussed earlier also. So now let us click OK. What happened, you see. So this is what we have seen, that the observed cumulative probability and expected cumulative probability, these things definitely will follow straight line, and you see ultimately the data set for backlash, it is on the straight line, but there is little peculiar curve, some S type of curve is there, very little, but S type of curvature is there. So if you see this one, or this deviation from normal and observed cumulative frequency for backlash, this much is deviation is there. This from PP plot you are getting. Now whether this deviation is within the acceptable limit or not, so that you have to look into. Now if you see normal probability float contact also, you are getting like this, and the deviation from normal it is given. Now what is deviation from normal, what is deviation your for backlash, what is deviation from normal for contact, those things you must understand properly, and that theory you must know. So in addition, here what we want to do, suppose we are going for QQ plot, then let the take the same thing, same two variables, again normal. Then I think what we want here, I want to give the confidence interval, proportion formula, transformation, standard absolute difference, break highly this, proportion estimation formula. It is not available here. Okay, let it be 2k. We give what is the difference I want to see. Natural audience. Okay. Then see, this is also, this is little different, means showing slight departure compared to PP plot, and it is obvious departure. So this is for your contact. This, but the difference count, nothing else is developed here. Okay. So okay, fine. Then let us go to the that report, descriptive statistics. There are many things. Then table you can prepare, RFM analysis, compare means. Now in compare means there is one link which is one way ANOVA. Let us develop this one way ANOVA now. So when you what you require to do, go to analyze, then go to compare means, then click one way ANOVA. Okay. So then here you have to see that what are the dependent variable, and I think all of you know that ANOVA model. ANOVA we said that treatment or population, this side that 1 2 like this, suppose there are L population, and then there will be one dependent variable, let it be y, and observations 1 2 like in. So here several observation, here second one several observation. So like this, by one way ANOVA we want to test whether these treatments, different treatment or different label or different population have effect on this dependent variable or not. That is what we want to test. So now here, although dependent list is there, if you put more than one variable, it will basically do one way ANOVA for repeatedly for different variables. For the time being, let us give only one variable backlash. Fine. Then what is your factor? Factor will be, I think it is, I don't know whether these are all coming under speed nominal. Anyhow, let me give the feed one. Then there is contrast. Under contrast, polynomial, degrees of freedom, coefficients, coefficient this. So here contrast nothing is shown except polynomial. Now you can go for post hoc, that post hoc analysis. Here you can get the under equal variance, you can get the LSD, you can get Bonferroni, you can get Taki, so you can get Waller-Duncan. I think we have described LSD, Bonferroni and Taki approach. If your equal variance is not assumed, then these are the different measures which are possible. So let us do LSD and Taki and Bonferroni. Okay. Now there is option, under option what are the statistics you want, that is given. If there is any missing values, so how do the analyze this missing value that is given. Okay, let us put OK. So what you are getting here, you see one way ANOVA, that post hoc tests are not performed for blacklist because there are fewer than 3 groups. Basically only 2 groups are there, that we have taken the feed variable is having 1.1 and 1.2, that are 2 labels are there. So let us take some other variable. For example, compare means, one way ANOVA. I am not taking feed here, I want to take speed. The same thing, let us do what is happening here. You see, because here more number of labels are there. So 6, 7, 8, 9, 10, then these 5 labels are there, 6 to 10, 6, 7, 8, 9, 10, 5 labels are there, and you are testing, that is the ANOVA table, you are testing whether if your speed is that level 6 or level 7 or level 8 or up to level 10, whether there is a difference or not. ANOVA table will give you this difference. This is the F statistics. F value is 78.109, very high. So there is difference. So in the same manner you can go for, suppose what I do, I will go for one more variable, compare means. I have taken backlash, but I also want to take contact here, put here. Then your factor is only one here, that factor speed, but you can, as it is one way ANOVA, so only one factor you are considering. Now if you put OK or click OK here, what you are getting? You are getting for backlash and contact separately. All tests, everything. So it's just a one click business. Now we will go for regression. So your data set is this, and we have described earlier that our backlash and contact, these two are dependent variable, and we say others are independent variable. So now go to analyze. I want to do regression, go to regression. Under regression, what are the different options available? You see, there are linear regression, then there is curve estimation, that or curve fitting, then there is partial least square, PLS, there is binary logistic, multinomial logistic, and you can go for ordinal regression, that ordinal logistics, then probit model, then nonlinear weighted estimation, 2-stage estimation, then nonlinear regression, your under then weighted estimation, 2-stage least square, and finally this is showing optimal scaling. So many under regression, so many techniques are available in SPSS. What we have discussed, we have only discussed linear regression. We have not discussed, basically linear regression is very popular, it will be partial least square regression is also very popular. All those logistic regressions including unknown probit, all are very popular techniques. So that means you can do linear regression, you can do nonlinear regression, you can do linear regression in under different condition. For example, logistic regression is used when the dependent variable is categorical. So binary logistics means dependent variable has 2 categories, yes, no, 0, 1 type of things. You can go for multinomial logistic regression when your dependent variable y has more than 2 categories. Okay. So probit regression is also the special type of regression where that categorization issues are there from the dependent variable side. Okay. So but we are interested in linear regression because this one only we have computed. So then what are the steps you have to follow for if you use SPSS. Then you go to analyze first, then click regression. If you click regression, then there will be a list here, the linear regression, you click. So, in SPSS, in analyze, you click regression, then click linear regression. Now, let us click linear regression. What is happening here? You see that one window coming up. That window, there is dependent, there is independent side, then there are different selection variable rules, case label, weighted regression, weighted least square, weights, everything is there. Okay. So, what you have to do first you have to choose your independent variable. So, as it is a multiple linear regression case, so your dependent variable will be 1, dB will be 1. So, which one is our dependent variable? Our dependent variable, let it be backlash. So, you click on backlash, then there is a arrow under dependent variable. So, when you bring mouse here, this become little larger, then you click here, your dependent variable column now is filled with that variable, dependent variable. Suppose you want to remove this variable, then the arrowhead, you see that immediately the arrowhead takes the reverse direction. So, click here, it is going up. So, if you want contact, click contact, come here like this. If you want to remove, do like this. So, let us take backlash. Now, what are the independent variables? When you click on independent variables, see there is no variable is selected so far. So, let us select all the variables. So, copper to humidity, they are the independent list. So, click here. Now, question is what method you will use here. The method is enter, stepwise, remove, backward, forward. These are all basically different types of treatment for the independent variable, inclusion of independence. If you say enter, all variables means all independent variables will be taken at a time and the estimates will be given. If you say no, you want to go for stepwise regression, then depending on the certain criteria, that inclusion exclusion criteria, that stepwise regression will be performed. If you go for forward or backward, forward selection, backward elimination, or forward selection, backward elimination, this type of model, it is possible. So, let us take only enter, because we want to see first enter. Once you make enter, that means you are considering all the independent variables simultaneously. Then you want to select some of the statistics. What are the things you want? Under this regression coefficients, then the residuals related things are given. So, you want the estimate, you may be interested to know the confidence interval. Now, what is the confidence interval level? 95%, 90%. If you want 95%, fine. So, under regression coefficient, first you click on estimates. If you do not click on estimate, it will not be displayed. So, confidence interval, if you are interested in covariance metric, click covariance matrix, model fit, R square change, descriptive, part partial correlation, all those things are there. You may be interested to know what is the autocorrelation, the Durbin-Watson measure. You may be interested to know the case wise diagnostics, outlier, outside 3 standard deviation. Okay. So, now you may be interested to know the R square change also, then you click R square change. If you are not interested, forget this. I think model fit, estimates and confidence interval and the some outliers and residuals related information are very important. click. Then there are plots. What type of plot you want to see? In regression, multiple regression, what are the plots I have said you? I said you that test of assumptions, if you can remember test of assumptions, then there are many plots. We said normality plot, normality of error terms, then we said the fitted versus residual, then we said the partial residual plot, then we also said that autocorrelation plot, okay. So, similarly many plots we have seen. Now, let us see that we want to find out that linear regression plots here, what are the things given, the dependent and independent. Basically what you want, dependent variable, fine. Now, in this independent side, which one you want, in predicted, residual, adjusted residual, student that praise, student residual, so many things are there. Let it be the predicted one. Okay. Now, you go for produce all partial plots, then you may be interested in histogram, you may be interested in normal probability plot. So, you continue. Now, there is save option. In save option means in what will happen, suppose you I am saving unstandardized predicted values. Let it be that residual unstandardized residuals you want to save. Model diagnostics also, suppose Cook distance you are interested to know, that leverage values also you are interested to know. Okay, this is fine. Now, options, there are large number of options also, U probability F for entry and removal, then how to handle missing values, these things are there. Whether you want constant in the equation or not, that is also there. Okay, click. Then once you click, what is happening, you see, it is running, I think. Okay. So, now regression variables we say entered. So, all independent variables are entered here. What is the R square value? That is 78.7%. I think you can recall my class. There I said that for backlash 78.7% variability is explained by the regression model, and adjusted R square is 76.5%. Okay. Now, see the analysis of variance table is coming here. This table is very important because this will tell you the hypothesis H0 beta j equal to 0 and H1 beta j not equal to 0 for at least one of the regression coefficient, one of the variable influence is not 0. Then you see this is the parameter estimates. So, constant, copper, silicon, all those things, and these are the beta values. These are beta values, mean this values only, beta cap equal to x transpose x inverse x transpose y. So, this beta cap, these values you are getting here 1.35, then 0.009, 0.013, then minus 0.009, like this values you have got. Now, come back to this SPSS output. So, see these are the beta, then standard error, then standardized coefficients. Mean if you have taken original variable values, you can standardize the variables, and then the standardized regression coefficient you will get, that is t value also you will get, and significance. If you see the significance level, and if we consider that 0.05 level is considered to be acceptable to reject the null hypothesis. So, then you see that hardness, this one here, this hardness, if I click this, see this one is 0.30. So, this is significant. Second one, speed is significant and depth of cut is significant. Speed, depth of cut, then speed and hardness, these are significant. Okay. So, we have seen earlier also that has happened. Now this coefficient correlations between each coefficient, whether they are related or not, that humidity to humidity, like this coefficient matrix also given, the covariance matrix between the coefficients also given. I think you know that covariance is covariance of beta. We have discussed covariance of beta cap. This one is x transpose x inverse what? S square. This one. So ultimately you are getting these values. Now residual statistics, you see that predicted value, standard predicted value, standard error, all those things are given here, mean, standard deviation, everything is given here. What you want, almost everything will be available from SPSS output, and whatever the options available or the outputs available here, that is sufficient for your work. Then go to the charts. This is the error histogram, residual, correct. So residual histogram part, and it is with the probability distribution also, that normal distribution curve, it is almost normal. Now you see the observed probability versus expected probability, expected cumulative probability versus observed cumulative probability, that is PP plot of errors. This is also across the straight line, so that is fine. Now you see backlash versus regression predicted values, it is a linear, clearly linear regression. Okay. Now you see that backlash versus copper, that is basically dependent variable backlash, that partial plot. If copper is significant, what will happen? That means either this copper contributes positively or negatively, then there will be a regression line, there will be a straight line. If it is positive, it will go up, and negative, it will go down like this or this, but the slope will be as per the beta value. Okay. So here copper is not significant, and that we have seen also. Similarly, your backlash versus silicon, similarly your backlash versus nickel, then backlash versus phosphorus, then it is your hardness. Hardness has little, you have seen that it is, hardness is negatively contributed. You see that one, that all the values, that residual values, that partial in this partial plot, what is happening? It is one straight line can be framed here, this way, getting me. So now you see that we have seen that feed also, speed have significance, influencing variable. So this residual plot also, that what we have seen in residual plot, we said that when you go for residual plot, this is basically xj, this side is error plus xj beta j cap. So then as speed is having negative effect, see the plot is like this. This is partial plot. When there is no effect, you will be finding out like this. There is suppose one variable, that epsilon plus beta j xj, then there will be mean that 0, and it will be like this. If that xj variable has no effect, for example, xk no effect. Okay. So that we have seen earlier. Now let us see other plots, what happened feed versus backlash. Basically there are only two, 1.1 and 1.2, that two, in these two places feed is that errors are also scattered under two different groups. This is a little, see, that means at the when you feed will change from one level to another level. So, what is happening ultimately, the backlash property also changing here, and I think it is the way it is represented here, it raise some questions. Then you go to backlash vis-a-vis depth of cut. Depth of cut has, I think, a positive relationship. So, you are getting a positive line here, a positive slope will be there if you fit a regression line here. Okay. Then humidity has no effect on backlash. So, you are getting straight away what you are getting here, it is a random one. So, there is no systematic part. Okay. So, these are the things what you want from this regression. Okay. Now, then what happened to your data matrix? You see that we have stored some of the something we have stored here. You see that our original variable was up to contact, then predicted values, residuals, Cook distance and leverage points, these are stored here. Getting me? So, SPSS will give you the output as a data vector. For every output you will be getting stored into this spreadsheet, and which can be used later on. Okay. Now, we want to see that we want to do multivariate linear regression using this SPSS MBLR. In MBLR you have more than 1 dV. So, it is basically greater than dV greater than equal to 2, this case. And what you have seen here? You have seen here in regression, suppose go to analyze, then obviously as it is multivariate regression you will click on regression. Then you go to that linear, but there is nowhere multivariate part is there. So, if you click linear, here option is only one variable can be given under dependent, it is says the dependent only. So, that means you cannot do under this regression that regression link or regression option. You have to go to other place, what is known as general linear model. Okay. If you go to general linear model, then there is univariate GLM, general linear model is known as popularly known as GLM. Okay. So, general linear model, there is another linear model which is known as generalized linear model. So, general linear model, then generalized linear model. So, this one is general linear model, We will go for general linear model, not generalized linear model. Their difference is generalized linear model, that in this case mainly when the dependent variable is non-normal, that time that logistic regression or your Poisson regression, those things are come under generalized linear model. For example, let us first do this general linear model univariate case. You click, what is happening when you are saying univariate, then dependent variable will be 1. So, under this there are fixed factors, there are random factors, there are covariates. Getting me? So, 3 things are there. One is dependent variable, fine. Then there are under independent side you have fixed factors, you have random factors, and you have covariates. What does it mean? Fixed factors basically the factor and it has different levels definitely, but these values are fixed. Random means what will happen, that value may change. Suppose if I say that label is 1, 2, 3 here, these are 1, 2, 3 is fixed, but in case of random it is not like this. So, random effect model is there. We are basically considering fixed factor model, and covariates is if the factor is continuous. Getting me? For example, my dependent variable is y, dv is y. Suppose this is beta 0 plus beta 1 x 1 plus beta 2 x 2, like this. Suppose this one is continuous measurement and this is different level, that means categorical or nominal, you can say. Correct? So, then you accordingly you have to put where you want to put. So, our case is dependent variable is backlash, put here, and we are interested in the covariate side, because all other variables all the variables here, if I take all up to humidity under covariates, what will happen, you see. Okay, then the model is there, full model and custom model, there will be different interactions, 2-way, 3-way, all interactions are there. I think let us go to the multivariate side, the similar nature, because I am interested to show you the multivariate part. Then what you will do, you cancel it, you go to analyze, then go to general model multivariate. The difference is everything remains same, difference is dependent variables, more than one variable. So, let us do like this, backlash one variable and your another one is contact, second variable. Okay. Now, let me take all the variables in dependent side up to humidity under covariates, is coming everything, but the symbol is giving here as if they are measured in nominal scale. So, I will go back and I want to see here why, but all are numeric, then why suddenly that symbol is given in this side type of things. I want scale, this one should be scale, this should be scale, this should be scale, this should be scale, this should be scale. Okay. Go to data, then go to analyze, go to general linear model, multivariate, then okay, fine. Now, backlash is your first dependent, contact is second dependent, then copper to humidity, put under covariates. What model you want? We don't want interaction here, we want custom model. Here we want only main effects, then you click all the variables here, this. Getting me? What happened? You have taken all the independent variables, you are taking main effects only, that means there is no interaction effects between the independent variable. If there is interaction effect amongst the independent variables, they are not truly independent. So, that we don't, we are going for multivariate regression where IVs are truly IV. Okay. So, then you continue, and usually we use type 3 sum of square, include intercept, continue. Then contrast, we don't require to have any contrast in this case, it is a that. Then you go for plots, what plot you want, if you want, I think here no factors we have considered, so plots are not, that's why not given. Now, your save options are there, you can save unstandardized predicted values, unstandardized residuals, Cook's distance, leverage values, and you can create coefficient statistics like linear regression, that everything is possible here. There is option also, you may be interested to know the factor interaction, is nothing is there. So, there are so many things. For example, I am interested to know the SSCP matrices, residual SSCP matrices, then homogeneity test you may be interested to know, then residual plots,
Okay, let like this. So click. Okay. Now first is Bartlett's test of heredity. It says that this is 0, that hypothesis test. What is this? That there is, what is the Bartlett's test of heredity? That data is that y variable here in, they are not related here. So we are basically it is 0.00, then H0 is rejected. Test the null hypothesis that the residual covariance matrix is proportional to an identity matrix. Okay, this one is rejected. Now design intercept, this is our model, beta 0 plus beta 1 x1, like this is our model. And you can remember I said in multivariate regression, Pillai trace, Willis lambda, Hotelling trace, Roy's largest root, these all values for every variable it is computed and their significant level were tested. 0.05 level, copper is not significant, silicon is not significant, nickel not significant. You see, this is the case. So ultimately you are finding speed is significant, speed, then your this speed 0.0004, then your feed is also significant here, then your depth of cut is significant, but humidity not significant. Okay. So this is for what? This is for which variable they are considering. In totality it is considered that design exact statistics like this, and this is test between subjects, mean square, then your some squares, mean square, like this. That some square degrees of freedom, individual variable, that contributions, it is also found out and their significance level is there. Then you see that SSCP matrix between subject, SSCP matrix related to regression, then residual SSCP matrix, this is the error one. Okay. So now you for backlash, for contact, SS cross product, then covariance and correlation, it is given here. Okay. Now see that dependent variable vis-a-vis predicted. Ultimately what we found out that observed versus predicted, if you see there is relationship. So observed, predicted, observed, nothing is there, that residual versus observed and residuals versus predicted, that should be random. So that is what is happening here, it is random. So similarly that for this is for backlash, other one for contact, and these are the things what you want, you are getting everything. So you are getting the test statistics from adequacy point of view, you are getting the individual regression coefficients and their test which one is significant or not, and you are also getting the model diagnostics related values like residual plots. So if you know the theory and if you are really applying multivariate statistics, then SPSS is a very good tool. So you can use SPSS, you can use Minitab is there, you can use SAS is there. So there are many statistical softwares, SPSS, Minitab, SAS, Statistical, SysStat. So I know this many stat graphics earlier I was using long back, but I don't know present status. But usually this SPSS, Minitab and SAS, these are available in our department, and you can use those things in the laboratory. Okay. So this is what is our multivariate linear regression using SPSS. So ultimately we have covered many things, but only one thing we could not cover to now, this MANOVA part. I think in some other class
I will show you that how MANOVA will be used using SPSS, and Minitab also we can think some class for Minitab. Okay, any question? Okay, thank you very much.